We've been talking about free body diagrams, and we have been uh, emphasizing the importance of free body diagrams as one of the most important things you need to know to draw and use for statics. Remember, what was a free body diagram? It's a drawing that shows all the external forces acting on the particle. Why? Because it's key to being able to write the equations of equilibrium. So you draw a good free body diagram and you can forget about the original drawing and just keep working with it. Now, we have seen this cylinder before, and we have been drawing free body diagrams where we showed all the external forces that act on the particle. So if we had just this part here, we said, well, we'll isolate it and then have the cables, which are the external forces, and the weight, and that's my free body diagram. So we were drawing active and not always the reactive forces. Now we're going to identify all of those forces, including the reactive forces. So now you'll be able to draw a free body diagram, including these reactive forces that are in these support reactions. So as a general rule, and we started discussing this already, if a support prevents translation of a body in X, then you have a reaction force in X. If you have a rotation that is prevented, then a couple moment is exerted. So like in this case, you have a roller, and the roller can move up and down. There's nothing that prevents it from moving. But then in this case, you have no translations in this direction, and so this is your reaction force. In this case, or in the roller case, you have here something that allows it to rotate, so there's no moment. The same thing whenever we have smooth pin. Remember I mentioned the importance of knowing that it's a smooth pin. So this prevents translation in X and in Y because it's fixed. You can see here it's fixed. But then the moment is not hindered, so there's no moment in the reaction. If you have a fixed support, then in that case, it cannot move in this direction, it cannot move in this direction, and it cannot rotate. So that's why you have all the moments. And you can assume one direction, and you'll see how, if the direction is wrong, you'll get a negative sign. So you have this type of object here. Now, what is important here is you have a pin, okay? So if I'm saying that it's fixed, then there is a moment. But if it's not fixed, there's no moment. And you can see a view, a side view of this, and you can see that this here is on an axle that can rotate. Even if it's fixed on the other side, what you look is at that specific reaction. Okay? So here is the same thing. You have a pin, and there's only the reaction here in Y. And we have this type of support as well. It's just resting on it, resting on this. It's just resting on this, and it's just resting on here. No moment. You have then the supported objects or a fixed support here, and then you have a Y, a X, and also a moment. In this case, it's just resting on it. So you have this. Now you have these other types of supports, and they're equivalent as well. So this cannot move in this direction, but it can move in this X direction. Same thing here. Same thing here. So you only have this. I hope you're getting the hang of it. So this is that kind of a summary of the supports. You have a rope or a cable. Of course, you have the tension here. If it's the contact, what you need to remember is that the force is perpendicular to the surface. So it's a normal force. Okay? Not normal to the object, but to the surface. Here, same thing. It's normal to here, the surface. and then of course you have, but there's no moment here. Same with the pin support, the roller support, there's all equivalent. This is a constrained pin or slider, but it can move in this direction, so that's why you also have A and then the fixed. So these are just a reminder of the different supports. Okay, so now we're going to draw the free body diagram, including the support reactions, which is something we didn't do before. So here's the fixed support, so you have a moment, AX, AY, and then you have, of course, the weight, which is in the center of gravity, and then the forces. So procedure is, you draw an outline shape, which is what's done here. Imagine the body to be isolated or cut free from its constraints and draw its outline shape. Show all the external forces in a couple moments. This includes applied loads, support reactions, and the weight of the body. Okay. Then you have to label all the loads and dimensions on the free body diagram. All known forces in a couple moments should be labeled. For the unknown forces, use letters like AX, AY, or MA, and if it was a three-dimension